Okay, so we're doing chapter 6.6 right now, which is solving radical equations. We're going to get right into the vocabulary. This section there's parts of it that I think are going to be very easy for you. I think a lot of you, when dealing with algebra, you're very comfortable doing equations and solving equations and knowing what you need to do. So I think that's an important part. So that's going to be a good part. The other part is there's going to be one point, the very last example that we do, that is actually going to be fairly difficult, so you'll have to follow along. This video may end up having to be broken up into two videos, so we'll kind of gauge that as we go through this. So starting with vocabulary, equations with radicals that have variables in the radicands are called, really basic, radical equations. Kind of a really weird definition there. And then the second one, which is actually more important, an apparent solution that must be rejected because it does not satisfy the original equation, is called an extraneous solution. And you'll see what that is later on in the section. But basically what we're doing is we're solving radical equations. So what does that mean? We're solving equations that have radicals in them. And what we have is we have three steps here that will help you do this. The first step is to isolate the radicals. So in other words, if the only thing that you do, if you don't have only a radical on one side, then you need to move as much stuff as you can until there only is a radical on one side. Okay, and then the step two is just to raise each side to whatever power you need to get rid of the radical. So if it's the fourth root, you'll raise to the fourth power, third root, third power, etc. And then the last part is to just solve the polynomial equation using anything else that we've done. Sometimes you'll have to use factoring, sometimes it'll just be linear. Okay, it'll just, you'll see that as you come to it. So let's get right into this. So our radical here is already isolated. So our first step is just to simply raise both sides to the third power because we have a third root. So that means that the root and the power will cancel out. So we will be left with 2x plus 7 equals 3 to the third power, which is 27. And now this is just a linear equation, so we're just going to solve it as we normally would. Minus 7, minus 7. 2x equals 20. Divide both sides by 2, and we get x equals 10. That should be fairly straightforward, especially this part down. Okay, that's really Algebra 1 stuff, probably even a little bit before that, 7th, 6th grade stuff. Okay, next one. So what happens when we don't have a radical? Well, remember, fractional powers are pretty much the same as radicals, but sometimes we'll have something up in that top number. So here's a good explanation. When an equation contains a power with a rational exponent, that means fraction, first isolate the power. So same thing as the radical. We need to isolate the power function first, or the power portion of it. Then what we're going to do is raise each side of the equation to the reciprocal of the rational exponent. So if your exponent is, say, 2/3, we will raise it to a power of 3/2 because then they'll cancel out. If it's 1/5, then we would raise it to the power of 5/1 or just 5 to get rid of it. Okay, so let's get right into this example. Again, the first thing we have to do is make sure that this part is isolated. So we have to get rid of our 3. So we will first minus 3 minus 3 from both sides. Minus 3, minus 3. So this will end up being 4. So we have x plus 2 to the 1/3 power equals 4. So now, as we said before, the idea here is we need to eliminate this 1/3 power. So the way we do this, and I'm going to write it all out for you, I'm going to have two parentheses. It'll be x plus 2 to our normal 1/3 power. And then the outside, we will raise it to the 3/1. Now, you don't always have to put 3/1. In this case, you could have just said 3. So we will do that to both sides. So it'll be 4 to the 3rd power, and we have x plus 2 to the 1/3 to the 3/1. Again, the reason why we're doing this is these just cancel out. So we are then just left with x plus 2 equals 4 to the third power, which is 64. Minus 2. Minus 2, and we get x equals 62. So now on the back side of your notes, this is a little bit different. It does get a little bit more complicated. It's not always going to be as easy as those front examples. I thought those front examples were not too bad. But basically, what we're going to be doing here is this is where the extraneous solutions comes in. So it says raising each side of an equation to the same power may introduce extraneous solutions. Therefore, you should always check each apparent solution in the original equation. So let's just go through and solve this. What we're going to get here is we need to get rid of this radical, and it is by itself. So we are going to square both sides. So this will be x plus 1 squared, and then the squaring of this side will get rid of that square root. So it'll be equal to 7x plus 15. So now moving on to the right, I'm going to square this first. And again, remember to FOIL it. If you're going to multiply it out, make sure you FOIL it. See, I can do a squared function without having to actually put two different factors here. I know that this is going to be x squared plus 2x plus 1, and that's going to be set equal to 7x plus 15. So from here, what we want to do is, because it's a quadratic, because we have squared, we need to move everything to one side and get this equal to 0. Because then we can either use our calculator, or we can factor, or we can use the quadratic formula to solve. So I'm going to go ahead and subtract 7x from both sides. So I'm going to change the colors here so that way you can see we're moving on. We have x squared minus 5x plus 1 equals now 15. Now we'll minus 15 from both sides. And we have x squared minus 5x minus 14. And that's all going to be equal to 0 because we got rid of everything on this side. So from here, what we want to do is we're going to factor. So the factors that we get when we do this are x minus 7 and x plus 2. Again, how did I get that? Well, I knew it was going to be x and x because it's x squared. Here we have minus 7 times positive 2 is negative 14, and minus 7 plus 2 is negative 5. That's how I know that those are our factors. So our apparent solutions are x equals 7 and x equals negative 2. So here's where we're talking about extraneous solutions. You should always check your solutions. So that's what we're going to do. I'm going to check x equals 7 in my original equation. So what do we get when we put in x equals 7? We get 7 plus 1 equals the square root of 7 times 7 plus 15. So that gives us 8 equals the square root of 64, which is 8. So we have 8 equals 8. Good. That means that we know x equals 7 is one of our solutions. So now let's do it with x equals negative 2. We have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So this gives us negative 1 equals a positive 1. So that's where we have a problem. So therefore, this cannot be one of our solutions. So we know that x equals 7 is going to be our solution, our only solution in this case. So x equals 7 is the only solution. X equals negative 2 is extraneous. And that's where that terminology comes in. So when you're checking for extraneous solutions, that would just be the one that does not work. So therefore, it's not a solution. So x equals 7 is really the only solution here. That's why it's very important to check your work. Don't forget to do that. Okay, so we have 5 minutes left. We are going to try and get through this problem instead of create a whole separate video. So this one is a little bit tough because it says squaring twice. When an equation contains two radicals, you may need to square each side twice in order to eliminate both radicals. Well, squaring it twice is not the difficult part for you guys. It's going to be what happens when we square this side right here. So what's going to happen here is we are going to square both sides like we normally would, because we wanted to get rid of this radical on the right-hand side for sure. So what happens is this. We end up with, this is easy, the square root goes away, but over here, again, we can't just simply square both of these and put it away. We have basically two binomials that we need to multiply. So this is going to be the square root of x plus 6 minus 2 times the square root of x plus 6 minus 2. So you're going to treat this first one, square root of x plus 6, like your x term. So when we FOIL, it'll be this first times first. So that will be the square root of x plus 6 times the square root of x plus 6 will be x plus 6. Then we will do the outer, so negative 2 times the square root of x plus 6. Negative 2 times, that's our inner, square root of x plus 6, and then our last, which is negative 2 times negative 2, which is plus 4. And all of that will be equal to the square, nope, sorry, not the square root, will just be equal to x minus 2. So now, if we combine everything here, we have x plus 6 minus 4, because there's negative 2 and negative 2, root x plus 6 plus 4. Now what I'm going to do is, because we're still left with a radical, we need to isolate this radical right here. So we need to move everything else to the other side. So what I'm going to do is 6 plus 4 is 10. So let me rewrite one more line. So we have x minus 4 root x plus 6 plus 10 equals x minus 2. So now what I'm going to do is I'm going to move everything to the other side except for the radical. So I'm going to minus x. I'll put this in a different color so you can see what I'm doing. And I'm going to minus 10. Minus x minus 10. So my x's cancel out, and my x's cancel out here too actually. My 10's cancel out, and we have negative 2 minus 10 is negative 12. So moving on to the right here, we have negative 4 root x plus 6 equals negative 12. Still, we have to get rid of this negative 4. Divide by negative 4. Divide by negative 4. So we are left with the square root of x plus 6 equals positive 3. Again, we're going to square both sides. This is back to where what we were doing before. Squared, squared. So this is the second time that we've had to square this problem. So we're left with x plus 6 equals 9 minus 6 on both sides, and we get x equals 3. All of that work just to get this one solution. So again, to recap this, we squared both sides like you normally would. But the problem was that with this first part, because we had this minus here, it meant that we were going to have a little bit more of a complex problem because we had to FOIL this. So we did the square root of x plus 6 times the square root of x plus 6. That was equal to x plus 6. Then we did the outer, negative 2 times root x plus 6. Then we did the inner, negative 2 times root x plus 6. And then the last, negative 2 times negative 2. That was equal to 4. We combine these middle terms right here to be negative 4 root x plus 6. We combine the 6 and the 4 to get 10. And then we proceeded to move everything to the right side of the equation, so we were only left with our root x plus 6 again. And then we had to square again for the second time to solve. So once we got to this point, it shouldn't have been that difficult. The difficult part was foiling this part right here. So again, if you have any questions, bring those to class. And I hope that this section wasn't that tough, and this kind of rounds out the end of the chapter. So see you guys tomorrow.